Here us to sketch the graph of the polynomial p of x here, state the degree of the polynomial and end behavior of the function. So first of all, I'm just going to rewrite this to show you kind of how I would look at the degree here. I'm going to expand this x minus 3 to the power of 3 so that you can see how many total x's we end up having, right? If I were to multiply all these things together, right, I would multiply all of these x's together and I would get 1, 2, 3, 4, 5. I get my first term would be 2x to the power of 5. And so that tells me that this is going to be a fifth degree polynomial, which normally I'm going to have something that looks kind of like this. If it's positive, because it's going up 1, 2, 3, 4, and 5, that's fifth degree. But we don't know exactly what it's going to be like this, but it does tell me the end behavior. So degree is 5, end behavior is going to be, as we go to the left, we're going down towards negative infinity. As we go to the right, we're going up towards positive infinity, and I'll write that out after I'm done graphing. So graph here in blue, we got to do our x-intercepts. We have 0, positive 3, and this one here, just to make sure everyone understands, would be negative 1/2. So when I negative, oh man, that is nice and zoomed in here. We'll make this nice and right there. So when I am graphing this, the other thing that I want to do is I want to find y-intercepts. In this case, I'm already given the y-intercept at, x equals 0, so I don't have to worry too much about it. But then I'm going to look through what are the three different possibilities that I could have at these intercepts. And I basically just look at the, exponent next to them. So the first one is power of 1, second one is power of 3, and third one is power of 1. The power of 1s are going to be going through them. So in this case here, I'm going to go through and through. Then the third one here at positive 3 is a power of 3. So I'm going to, what I like to call a swoop through. It's going to look kind of like a cubic function where it kind of makes that bend like that. And so there's my zoomed in graph. It does go on forever to the left and to the right though. So when I write my end behavior here in green, I say as x goes towards negative infinity, which means the left side, y is going towards negative infinity because it's going down. As x goes towards positive infinity, which is the right side, my y values are going up, so I say it's going towards positive infinity.